Today we are going to learn about mastering data cleaning with Python, a practical guide. We'll dive into essential data cleaning techniques using Python libraries like Pandas and NumPy, equipping you with skills to effectively clean and prepare data for analysis. Welcome to Mastering Data Cleaning with Python, a practical guide. Data cleaning is a fundamental step in data analysis and machine learning, ensuring that the insights drawn from data are accurate and reliable. Poor quality data can lead to misleading results and faulty decisions. In today's video, we will explore how to effectively clean and prepare data using powerful Python libraries like Pandas and NumPy. By the end, you'll have the skills to handle missing data, remove duplicates, fix inconsistent formats, and much more. One of the first hurdles in data cleaning is dealing with missing data. Missing data can manifest in various forms, such as NaN values, blanks, or placeholders like n/a. These missing values can skew analysis and lead to incorrect conclusions. Using Pandas, a powerful Python library, you can easily identify missing values with functions like isNull and notNull. Once identified, you have several strategies to handle them, such as removing rows with missing data using dropNA or filling them with mean, median, or mode values using fillNA. Real-world datasets often have missing data due to human error, data corruption, or incomplete data collection. Understanding and addressing these issues is crucial for maintaining the integrity of your analysis. Duplicated data entries can significantly affect the quality of your analysis by distorting statistics and misleading results. Duplicates often occur due to errors during data collection or merging datasets. In Python, Pandas offers a simple way to detect duplicates using the duplicated function, which returns a Boolean series indicating whether each row is a duplicate. Once identified, you can remove these duplicates with the drop_duplicates function, ensuring that you retain only the first instance of each duplicate entry, or you can specify which duplicates to keep based on your needs. It's essential to perform these operations carefully to avoid losing important data unintentionally. Inconsistent data formats can create significant challenges for analysis, especially when dealing with large datasets from multiple sources. Common inconsistencies include varying date formats, inconsistent capitalization, or numerical values stored as text. These discrepancies can hinder data processing and analysis. With Pandas, you can standardize data formats using functions like _datetime for dates or str.lower and str.upper for strings. String manipulation is a powerful technique to clean and unify data, ensuring that all entries are in a consistent format, which is critical for accurate analysis and comparison. Data entry errors are common in datasets and can occur due to typographical mistakes or incorrect data input. These errors can severely impact the quality of your dataset and the results of your analysis. Python offers robust string manipulation capabilities to correct such errors. Functions like replace and strip can clean up unwanted characters or whitespace, while regular expressions provide a more advanced way to identify and fix complex patterns of errors. By proactively addressing these issues, you can ensure that your data is clean and reliable, leading to more accurate and meaningful insights.
Standardizing data is a critical step in preparing your dataset for analysis. It involves transforming data into a consistent format or scale, making it easier to analyze and compare. This is particularly important for numerical data, where differences in scale can obscure trends and skew results. In Python, you can use Pandas to apply scaling techniques like normalization or standardization, which adjust the data to a common scale without distorting differences in the range of values. Normalization rescales data to a range of 0, 1, while standardization centers data around the mean with a standard deviation of 1. Understanding and applying these techniques ensures that your data is ready for meaningful analysis. Pandas is a highly versatile Python library that is indispensable for data cleaning and analysis. It provides data structures like series and data frame, which are perfect for handling structured data efficiently. With Pandas, you can easily perform a range of data cleaning tasks, such as filtering rows and columns, transforming data types, and applying functions across the dataset. The library's intuitive syntax and extensive documentation make it accessible for both beginners and experienced users. Whether you're dealing with a small dataset or massive datasets with millions of rows, Pandas offers the tools you need to clean your data effectively and prepare it for further analysis. While Pandas is excellent for handling structured data, NumPy provides the foundational capabilities for numerical data manipulation. NumPy arrays are highly efficient data structures that enable fast computations and are particularly useful for large-scale numerical data. The library integrates seamlessly with Pandas, allowing you to leverage its speed and performance while cleaning and processing data. NumPy's functions can perform element-wise operations, statistical computations, and more, making it an essential tool for data scientists and analysts working with numerical datasets. By combining the strengths of Pandas and NumPy, you can tackle even the most challenging data cleaning tasks with ease.
Data cleaning is often more complex in practice than in theory, with real-world datasets presenting unique challenges that require creative solutions. Common issues include dealing with incomplete data, managing data from multiple sources, and resolving inconsistencies in data formats. Through case studies and examples, we will explore how experienced data scientists tackle these problems, using a combination of techniques we've discussed, such as handling missing values, correcting data entry errors, and standardizing data. These real-world examples provide valuable insights into the practical aspects of data cleaning and highlight the importance of continuous learning and practice to refine your skills. Congratulations on completing Mastering Data Cleaning with Python, a practical guide. We've covered essential techniques for cleaning data using Python libraries like Pandas and NumPy, helping you ensure your datasets are accurate and ready for analysis. Clean data is the foundation of reliable insights and successful data-driven decisions. As you continue your journey, explore more advanced topics in data analysis and machine learning. Practice the skills you've learned today, and don't hesitate to dive deeper into the rich resources available online. Keep experimenting and refining your approach to become proficient in data cleaning and analysis.